Alright guys, I'm here to solve some problems for you on the Geometry Honors semester exam review. I asked you for your input on Remind, and I did get a good amount of responses, and I picked the most highly requested ones. So if you don't see one that you requested on this video, then you need to let me know tomorrow in class so that way we can go over that. Alright, so I went through and highlighted them, so I'm just going to do them in order, and I'm probably going to have to break this video up into two different videos. Okay, so number 7, it says, find the measure of angle CAB, and this is the vertex here. CAA is the vertex, and CAB, that's going to be this angle right here, okay? Well, the only two expressions we're given are the 6x minus 125 and the 2x plus 39, and we can see that they're vertical to each other, so we know that we should set those equal to one another, and then solve for x. So subtracting 2x, I get 4x. Adding 125 to 39, I get 164. And when I divide that by 4, I'm going to get that x is equal to 41. Now, that's not the final answer, nor is the final answer going to be when I plug it back into these. Because what you see is that the angle we want is adjacent and supplementary to the two expressions. So I could plug it into either one and then just subtract 180 from it to get the measure. So I'm going to put it into this one, the measure of angle BAM. So 2 times 41 is 82. 82 plus 39 gives me 121. So I need the supplement of that. So that's 180 minus 121, which gets us 59 degrees. So that is the measure of angle CAB. Okay. Number 9 asks, AB bisects angle CAT. So right off the back, I'm just going to draw an angle and label it CAT. A is the vertex. And then AB is the ray that bisects it. So we're going to have a ray starting at A and jutting out from the angle. And since it's an angle bisector, we know that this angle is congruent to this angle. It says the measure of angle CAT is equal to 8x minus 30. So the whole thing is 8x minus 30. And the measure of angle CAB, which is this one right here, is 2x plus 10. Find the value of x. Well, we know since it's a bisector, what we're going to have to do is double angle CAB to get the full angle, which is 8x minus 30. So I'm going to do 2 times 2x plus 10 and set that equal to 8x minus 30 and solve for x that way. So I'm going to get 4x plus 20 is equal to 8x minus 30. Subtract 4x on both sides, and you get 4x. Add 30, we're going to get 50, and therefore x is equal to 50 divided by 4, which is 12.5. Okay. On to the next one, which is number 20. It's the true and false section for these parallel lines. Or at least, I mean, we actually don't know if they're parallel, but we do know that we got some transversal stuff going on. We got some relationships that are happening between each of these, okay? It says angles 1 and 11 are corresponding angles. Is that true or false? Angle 1 is up here, angle 11 is down here. They don't even share a line in common, so they can't have a relationship with one another. So this is false. All right. Angle 7 and angle 5, so let me circle those. 7 and 5 are corresponding. Well, what we notice is if we just kind of zoom in and look at only those two, then 7 and 5 are on the underside of their lines, and they're both on the same side of the transversal, so that fits the definition for corresponding, so that answer is true. It says, since no lines have said to be in, since no lines have been said to be parallel, there are no corresponding angles in the picture, and that's false. And the reason why is because we don't have to have parallel lines to have these angle relationships. such as corresponding or alternate interior or alternate exterior or same side interior and all that stuff. The only thing that having parallel lines does is gives us like congruency between those pairs or supplementary relationships. All right, so it says angles 5 and 10 are alternate interior angles. Well, if you look, angle 5 is right here, angle 10 is right here. They are on opposite sides of their transversal, and they are both between lines A and B, so this fits the definition perfectly for alternate interior. And then it asks if angles 14 and 11 are alternate interior, and if you look at 14 and if you look at 11, they're both on opposite sides of line B, and they're both between lines Q and P, so they are also alternate interior angles. All right, next up we have number 24, which are congruent. Okay, so put a check next to them. The base angles of an isosceles triangle, those are congruent. Corresponding angles of parallel lines, we know that corresponding angles are congruent. The diagonals of a rectangle are congruent, and they also bisect one another. The diagonals of an isosceles trapezoid, those are congruent. The vertical angles, those are congruent. A linear pair, that's supplementary. Alternate interior angles, that's congruent. Opposite angles of a parallelogram, those are congruent, and the consecutive angles of a parallelogram, those are supplementary. All right, number 25, which are supplementary. It's the same list as above, so we know that it's the linear pairs and the consecutive angles of a parallelogram. Okay? Let's do a quick check. Oh, it's not letting me do it. Okay, moving on. The next one that we want that was requested is number 41. All right. So this one is kind of intense because it's asking which point below can be the placement of point S, which kind of means you need to try them all out. And here's how I would tackle this problem. This might not be how others would tackle it, but I know that this method works, so this is what I do. When you look at the congruency statement above, it says that triangle RAP is congruent to triangle ISD. And you are looking for a point S so that these two triangles can be congruent. And what we know about congruent triangles is that the corresponding sides have to be congruent. So, for example, RA and IS, they have to have the same measure. Well, given this triangle right here, I can find the measure of RA by either doing the distance between R and A, or I could do a Pythagorean's triangle and do it that way. I know that a lot of us have preferred this way. So what's the change in the y? Well, I went from -2 to +4, so that's a 6. And the change in the x is from -7 to -4, which is a 3. And when I do 6 squared plus 3 squared, what I'm going to get is 36 plus 9, which is 45. So the length of this is square root of 45. Now, I know that the length of IS must also be the square root of 45. So here's what we're going to do. We're going to try out going from A, B, C, and D until we get one that is going to have a length of square root of 45. So let's plot the first one. A is 3, 8. So that's going to be like all the way up here. All right, so I'm going to make a triangle. And let's see. So the change in the y from 2 to 8, I'm going to do this in a different color so you don't get confused. The difference from the height, so I start at 2 on the y, I go all the way up to 8, that's a 6. And then from 0 to 3, well, look at that, we lucked out. If you know that the sides are the same. So you see here that we have a 6 and a 3. We see here we have a 6 and a 3. So we know that 3, 8 works, and we lucked out, and the first answer is the correct answer. So there you go. That's how that's going to work. Okay. Number 42, it says the rhombus below has vertex coordinates shown. Find the coordinates of vertex S. Well, here's what you know. You know a rhombus has all congruent sides, which means that these lengths all have to be the same. So I can find the length of these sides by simply finding the length of one of them. So I'm going to use this right here to find that. The height is 3. The length here is 4. From 0 to -4 is 4. And when I do Pythagorean theorem, I actually find that this is going to be 5. Okay, and if you don't trust me, we can just kind of show that over here. So what's that going to be? 9 plus 16 is equal to 25. The square root of 25 is equal to 5, right? Okay. So it's actually, this is a special type of triangle. It's called a Pythagorean triple. 3, 4, 5, and any multiple of 3, 4, 5 would also work. Okay. So I know that all the lengths have to be 5. And therefore, here's what I'm going to do. I'm going to use R and just make another triangle. I know that I've kind of inverted my triangles, so that way this is going to have to be 4. This is going to have to be 3. And if I start at -4, -1, and if I go up 4, that's a change in the y. And if I go to the right 3, that's a change in the x. So my coordinate point for S has to be -1, +3. And that's what it looks like right there. All right, so there we go. That's number 42. A lot of these similarity ones that you guys requested is going to be done on Monday, or are going to be done on Monday, so I did not include them. However, tomorrow I'll ask for a second round, and maybe we can do it. I can do another video. So yeah, let's go. Okay, I'm actually going to stop the video here because I think number 56 is going to take a long time, and I don't want this video to crash while I'm solving it.